Good morning, everyone. I am Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In the last video lecture series, I have explained about the parallel communication interface and the serial communication interface. Now, my topic is about keyboard and display controller, that is keyboard and display interface 8279. The main features of keyboard and display controller are it is also having 40 pin, it is also having the address lines of 16 bit and the data bus of 8 bit. We'll see about the keyboard and display in detail, where it is a programmable keyboard or display controller which was designed by Intel, where it interfaces a keyboard with the CPU. The keyboard first scans the keyboard and identifies if any key has been pressed. It then sends the relative response of the pressed key to the CPU and then vice versa. This keyboard mainly works, and also it is interfaced in two modes, that is interrupt mode and the polling mode. In the interrupt mode, it mainly waits or requests the interrupt service. If the interrupt service is ready, if the interrupt service is okay, it checks whether any key is pressed. Otherwise, the CPU will continue with its main task. Next one is hold mode. In this, the CPU periodically reads an internal flag of this 80 to 79 to check whether any key is pressed or not with any pressure. Then the keyboard consists of maximum of 64 keys, which are interfaced with the CPU by using the key code. These key codes are debounced and stored in the FIFO RAM. Now, that with this FIFO RAM is 8, but FIFO is nothing but first in first out RAM, which can be accessed by the CPU. Then if more than 8 characters are entered in the FIFO, then it means more than 8 characters are pressed at a time. This is when it is set when it is in overrun status. If a FIFO contains a valid key entry, then the CPU is interrupted in an interrupt mode, else the CPU checks the status is in polling mode. Once the CPU reads a key entry, then FIFO is updated, and then the key entry is pushed out of the FIFO in order to generate the space for the next entries of the keys. This is the pin diagram. It is a 40 pin, as I said. Here IRQ is nothing but interrupt request, RL is return lines, SL is status lines, DB0 to D7 data bus, that is data bus is of 0 to 8 bit. As usual, it has CNTL is nothing but controller strobe pin. This data lines, these are 8 bit directional data bus lines, which is used to transfer data from R to the CPU. Reset, here in the name itself it says that it resets the microprocessor. Then a chip select is used. This pin is always low. It allows read or write operations, else this pin should be set to high. And as usual, read or write operation is nothing but it reads the data and also writes the data into the CPU. IRQ is nothing but a interrupt request. This interrupt output line goes high when there is data in the FIFO sensor RAM. The interrupt line goes low with each FIFO RAM read operation. VSS VCC is nothing but power supply and ground. SL0 SL3 is nothing but scan lines, which is used to scan the keyboard matrix and the display digits. RL0 or L7 is nothing but a return line, which is connected to the one terminal of the key, while the other terminal is connected to the decoded scan lines. These lines are set to 0 when any key is pressed. BD is nothing but a blank display. It is used to display during the digit switching. Then comes the architecture of 80 to 79. It also consists of data buffers, input output control, FIFO sensor RAM and FIFO sensor. Next is here display. It consists of various sections, that is keyboard section, display section, scan section. So in this display address registers, display RAM, display registers are comes under display section. Scan counter, registers, keyboard debounce and control, which are comes under the keyboard section, where IO control and the data buffer. This unit controls the overflow of data through the microprocessor. A control and timing register is mainly used to store the keyboard, display modes and other operations as programmed by the CPU. This scan counter has two modes, that is encoded mode and the decoded mode. In encoded mode, the counter provides the binary count that is to be externally decoded to provide the scan lines for the keyboard and the display. In the decoded scan mode, the counter internally decodes the LSB bits, that is LSB last two bits, and provides a decoded 1 out of 4 scan from, that is scan line SL0 to SL3. Written buffers, keyboard debounce and the control of this are used here. This unit first scans the key row wise. If found any key debounce, then the key entry is there. The key entry will be there. In case if the same key is detected, then the code of the key is directly transferred to the sensor RAM along with the shift and controls key status. Next one is FIFO or sensor RAM. First in first out, that is first one will be given the first preference. When the first key enters, it will be given it will be moved to the end until its operation continues. If there is not any interrupt request is given there. Next one is display and the address registers and display RAM. This is mainly used to write the word read or written by the CPU or from the display of the RAM. Various operation modes are used here, that is input mode, output mode. In input mode, scanned keyboard mode, scanned sensor matrix, strobed input are used. In output mode, it mainly displays the scan section. This is how the keyboard and display controller are used to interface with the microcontroller. Thank you.